Hello everyone, I'm Pallavi pursuing BE in Sri Venkateshwara College of Engineering. In this video, we'll discuss about data processing instruction under microcontroller and embedded system. So the content that will be covered in this video are introduction, data processing instructions, types of data processing instructions. So before jumping into data processing instruction, let us know about ARM instruction set. ARM instruction process the data held in registers and access memory only with load and store instruction. ARM instructions can only access the registers but not the memory. To access the memory, it should use load or store instructions. It commonly takes 2 or 3 operands. The instruction classes of ARM are as follows: data processing instructions, branch instructions, load store instructions, software interrupt instruction, program status register instructions. In this video, we'll be discussing about data processing instructions. Data processing instructions manipulate data within registers, that is, they control data within the registers. If you use suffix s on a data processing instruction, then it updates the flag in the CPSR. So if S is used as a suffix, then it is used for updating the flags in CPSR. That is, if there is a carry, then the carry flag C is set. If there's a negative, then N, negative flag N is set. And for 0, 0 flag Z is set. Types of data processing instructions: move instructions, arithmetic instructions, logical instructions, comparison instructions, multiply instructions. Let us look into move instructions. It is the simplest ARM instruction. This instruction is useful for setting the initial values and transferring data between registers. So the syntax of move instruction is instruction, condition, S, RD and N. RD is the destination register, N is the source register, or it can also be immediate value. Instructions are MOV and MVN. Here, MOV instruction just move the data from one register to another register. In MVN instruction, it negate the value of the source register and then it is stored in the destination register. Now let us consider an example. So pre is execution of the instruction before the execution of the instruction, and post is after the execution of the instruction. So before execution of the instruction move, R5 stores data 7 and R7 stores 3. So the instruction given here is move R7 and R5. That is, the content or the data of R5 will be stored in R7. So after execution of this instruction, R5 holds 7 and R7 holds 7. That is, the data of R5 will be moved to R7. So this is all about move instruction. So the next instruction is arithmetic instruction. Arithmetic instruction perform basic arithmetic operations like addition and subtraction. So the syntax for arithmetic instruction is instruction, condition, S, RD, RN and N, where RD is the destination register, RN and N are the source registers. Now the instructions that are available in arithmetic operations are ADC, that is addition with carry, ADD is addition, RSB is reverse subtraction, RSC is reverse subtraction with carry, RSC is subtraction with carry, and SUB is subtraction. So let us consider an example. The condition is R0 contains this particular data in hexadecimal form and R1 and R2. So the instruction here is subtract R1 and R2, and the data and that particular data will be stored in R0. So let us look into this example. So here this is a 32-bit data. So let us consider the last 2 bit. So the binary format of 2 is 0 0 1 0, and we have to subtract with 1. The binary format, so to subtract, we have to take 2's complement of 1, that is 1 1 1 1. So now you will get it as 0 0 will give you 1. 1 1 is 0 with 1 carry, and again 1 1 0 1 carry, and 1 1 is 0. It is 0 0 0 and 1. That is 1 0 1 is 1, 1 1 is 0 with 1 carry, 1 1 is 0 with 1 carry, 1 and 1 is 0. So which is nothing but 1. So here the last bit is 1. So now let us move into next instruction, that is logical instructions. These instructions are mainly used to perform bitwise logical operations on the two source operands. The syntax is instruction, condition S, RD, RN, and N. So the logical instructions are AND, OR, exclusively OR, and bit clear. Here, let us consider an example. So in pre, R0, R1, and R2 holds this data in hexadecimal form, and we are going to use the instruction AND. So now AND R1 and R2, and that data or the resultant will be stored in R0. So let us consider here in R0, as it is a 32-bit, let us do the last bits. So it is 4, which is 0 1 0 0, and B is 13 1 1 0 and 1. So for AND operation, when it is 0 0, it is 0 0 0 again, 0 0 1 is 1, and 1 0 is 1, that is 0 1 0 0. So when it is 0 1, it is 0 0 0, it is 1 1 1 is 1 as per the condition, and then 0, so which is nothing but 4. Here we got it 4. The same way it has to be carried to all the bits. So this is about logical instruction. Now let us move to comparison instructions. These instructions are used to compare or test a register with 32-bit value. It updates the CPSR flag condition bits according to the result, but do not affect the registers used. So the syntax here is instruction, condition, RN, and N. The instructions are CMN, compare, negate, CMP, compare, TEQ, test equality for 32-bit value, TST is test bit of 32-bit value. Now, in the pre-instruction, let us consider the CPSR flag, and let in R0 the data stored is 3, and in R1 the data stored is 3. So compare R0 and R1. Here only 2 operands will be used. So we are comparing both the registers. So let us consider this example now. So in R0 we have 3, and in R1 it is 3. For compare operation, we have to do subtraction, that is Rn minus n. So R0 is 3. So binary form of 3 is 0 0 1 1, and minus 3. You have to do subtracted. So 2's complement of 3 is 1 1 1 0 1 1 1 0 1. You will get it as 1 1 is 0, 1 1 is 1, carry 1 0, 1 1 is carry 1 0, again 1 1 is carry 1 0, and so on. So the output will be 0 0 0 and 0, that is 1 1 0 and carry is 1, again 1 carry with 1, that is 0 and 1 1 1 0 and 1 1 1 0. So as it is 0, the flag, zero flag is set. So in the post NZ, the zero flag will be set. So this is comparison instruction. So now let us move into multiply instructions. Multiplies the contents of pair of registers and depending upon the instructions accumulate the results with another register. So the syntax here is MLA condition S RD RM RS and N. So here there are four operands used and MUL condition S RD RM and RS. So MLA is multiply and accumulate, MUL is multiply. So let us look into an example. In pre, R0, R1 and R2 contain this data and multiply of R1 and R2, the data will be stored in R0. So after multiplying, the R0 contain this data in hexadecimal form and R1 contains the same data as there is no instruction that is applied on it. So this is all about multiply instruction and data processing instructions. Hope you like the video. Thank you.